8th grade science. This is the directions for the Phet wave interference assignment, and this will cover parts 1, 2, and 3. So if you find that assignment on Google Classroom, it is going to look like this. Here we go. And so this document has, like I said, all parts. I know for the in-person kids, I usually split up 3 from parts 1 and 2. So just know this covers everything. And this is what you're going to need. You're going to need the simulation open. And just like I think when we did motion energy, there are some of these little tutorial directions. So I'm going to go do that with you right now. So you know what to click on, and it helps remind me. So this is going to show you what to click on to get the simulation started. So you're going to click start. It tells me I need to click on waves. I need to click on the sound, the speaker looking icon, turn on the graph, turn on both, and then I'm going to drag my tape measure over and then click the green button to get started, and I should be good to go. So let's kind of copy that on our simulation. So I want waves, I wanted the speaker, turn on the graph, hit both, drag my tape measure over, green button to get started. Okay. So now if we go back to our assignment, what you guys are going to do, first question, you need to identify the medium that the sound wave is traveling through. In this case, it's those dots. Think about even just me talking to you right now, even if it's coming from your speaker to your ear, what is it traveling through to get there? That's also your medium. Same thing as what this one is here. If you look at that second question, are the particles on the screen moving up and down or left to right? You guys can do that after observing that. And then it says try and focus on one of the red particles, and you can turn on the slow. So that's down here, turn on slow. You're focusing on the red particles, and you're kind of describing their motion as the sound wave moves through that medium, which includes those red particles. Now here's just kind of like I wouldn't say food for thought, but just kind of a reminder. So a sound wave is a longitudinal wave, FYI, which is what we're looking at. We're looking at sound waves in that simulation. And it says longitudinal waves are waves where the medium is moving in the same direction as the wave, as we kind of looked at in that instructional video. There are 2 parts to that wave, which is the fun stuff, right? So there's something called compression, where the particles are close together, and then there's something called rarefaction, where the particles are far apart. So you're trying to figure out where's the compression and the rarefaction. I'm going to help you with this. I'm going to pause it. So where are the particles close together? It's kind of in these white rings here. That'd be the compression. And then the rarefaction would be the black parts where the particles are far apart. If you watch the instructional video, and we looked at that slinky, those waves, the part where the rings of the slinky were close together, that would be compression. And the part where they're like normally spaced or far apart, that would be the rarefaction in that longitudinal wave. So you guys got to identify those. Oh, looks like I already did. Let me get rid of that for when I make a copy. Now you're going to use the measuring tape, and you're going to measure how long the wave is from one compression to the next. So I think it helps to keep it paused. And really, when you do the measuring tape, see those little kind of orange plus marks? Try and just put one on one of the waves. So I did it in the middle of a white ring. And then you just drag it to the next one that's also in the middle. So try and keep it on the same part of the wave. I could probably just a little back. And then you write down that number, change the amplitude, and then kind of measure it again. And what I recommend, I can kind of show you. So if I change the amplitude, you need to let it kind of run for a little bit. So the wave has to kind of propagate from when you made the new amplitude. And you'll kind of see that on the graph here a little bit as well. Pause it again when you're ready, and then just you can drag so it's at the right spot again. You don't necessarily always have to change this unless you know the wavelength has changed. Because again, we're trying to figure out how does the amplitude and frequency affect the wavelength. Hopefully you know that already, but if you don't, there you go. Follow the directions again. Again, you're going to use your measuring. When you get to part 2 has its own directions, as you can see. You're still using that same main simulation, but if I remember right, you go to a different part. Let's double check. So in part 2, we're going to drag the amplitude back, and we're going to drag the frequency to half. And that's it. Oh, okay. So let's do that. I think I just have to do that because I didn't change the frequency like it said. Okay. In part 2, now you're mainly looking at the graph here. I'm going to change this. There. You're talking about what's happening to the wave on the graph when the amplitude is at max versus when it's at 1. And you're trying to kind of relate some of the changes to the energy and or how loud it is. And really, you're focusing on the graph here. This where it says this graph that you see, not necessarily the picture behind it, to kind of see that trend. And then the last one, part 3, is pretty short. Again, it has its own directions because this time you're using a different part. So you're actually going to go to interference here on the right, the next one. But again, you want the speakers turned on, you want the graph, and you want both. And then you just turn both of these on. And then you can answer those questions about what you see. This one usually goes pretty easy or pretty short. Okay, I think you should be good to go. If you're stuck, make sure you go back and click on those directions to make sure you have the simulation set up. And good luck. Have a wonderful rest of your day. Bye.